Hello, so in this section, I am going to address the concept of discounted cash flow technique to investment appraisal. Now, you may remember that we have dealt with accounting rate of return and also the payback. Now, these two methods have got one weakness. What common weakness they have? They ignore the time value of money. Would not take into account the time value of money in accounting rate of return and the payback method of investment appraisal. So the first question that we deal with is, what is this time value of money? Time value of money is the concept which says that $1 today is better than the same amount tomorrow. So why is $1 today better than $1 tomorrow? Or three reasons. Number one, a dollar today gives you what we call investment preference, meaning that once you receive $1 today, you can go and invest it and start to earn some interest. Secondly, the $1 that you earn today gives you consumption preference, meaning that you can go and consume this rather than waiting for tomorrow. The third reason is that you're going to enjoy risk preference, meaning that once you receive your $1 today, the risk or the uncertainty of you not getting that money disappears. And it's for these reasons that an amount receivable today has got a higher value compared to the same amount tomorrow. So the next question then is, so how do we incorporate time value of money in our investment analysis? The simple answer is that we incorporate time value of money via the concept of discounting. So what is discounting? Well, discounting is the opposite of a process called compounding. And next question then is, so what does it mean to compound? What is compounding? Please do not tell me that it's the opposite of discounting, because you may not get a 50 in your exam if you took that approach. So to understand the compounding, we're going to take a simple question, numerical analysis, which will help us see what is involved when we compound in investments. So we've got an investment opportunity here involving $100, which can be vested for 4 years, and the interest rate is 10% per annum. So our analysis is, let's demonstrate the simple interest and the compound interest on this amount. And in the process, we'll be able to see what is involved in compounding. Under simple interest approach, I'm sure you can see what is happening there. What is happening really is that over the 4-year period, the amount of interest that is earned is equal. How does that happen? So once you come to year 1, you invest 100, you earn 10%, and this gives you $10. In the following year, this interest earned is not carried forward. It's not included in your account. No, we assume it's paid out. So again, we only have 100 on which you pay interest, and then the interest is 10, and so forth. Even the years that follow, only $100 earns interest, and over the 4 years, only 40 has been earned, and plus the initial amount, then you have got a total of 140. How does this approach compare with what we see under the compound interest approach? Remember, our interest is what is involved in compounding. So let us see how the compounded interest approach differs with simple interest. So when interest is being compounded, what happens is that, as you can see, in the first year, $100, we earn $10. Then here, this amount is added to your investment. That is why in year 2 you have 110 now, which is the initial 100 plus the interest earned in year 1. That gives 110. So now interest is calculated on 110, and that gives us 11. The 11 is added to 110 again, so now we have 121, and so interest is calculated on 121. Again, we have 12.1 added to 121, giving us 133.1, and it's on there that the interest is calculated. So in this approach, interest is being compounded to your principal or your initial investment. And subsequently, higher interest amounts are being earned because the interest is carried forward and it also earns interest in the future years. So accordingly, you can see that total interest here is higher. 46.41 plus initial investment gives us 146.41. So this is what it means when interest is compounded onto your investment. So we have seen the numerical analysis here. Now let's look at the formula. This formula will give us a further understanding of what it means to compound interest on your investment. Let's look at the formula. So here's a formula. This is what we call a compound formula. A formula that you're going to use in financial management several times. This formula helps us to calculate how much an investment would be after so many years when interest has been accrued or added using the compound approach. So then, according to this formula, after so many years, the future value can be estimated by taking the present value or the amount today and add interest using the compound factor. So in compounding then, we're taking the present value and we say how much would it be after so many years. So after looking at the compound formula and also the contrast between simple and compound interest approaches, let us now conclude on what we mean, especially by discounting. So what is compounding? Compounding involves converting a present value, an amount today, into a future value by multiplying by the compound factor. So when you're compounding, you're moving forward, taking a present value and say what will it be in the future. What of discounting? When you're discounting, you are then converting a future value, a future cash flow, a future figure into a present amount. How do you do that? You multiply by the discounting factor. So then, in our investment appraisal process, we'll be determining discounting factors and we'll be using them to convert future values into present values so that all the figures can now be evaluated. And that is your formula there. To get a discount factor is 1 over 1 plus interest rate to the power n. What is n? That's the number of years. So if you want the discount factor for year 3, at 10% is 1 over 1 plus 10% to the power 3. For year 4, to the power 4. For year 5, to the power 5. Now, having looked at what discounting is and what a discount factor is, now we come to two methods. So there are two methods which apply discounted factor technique. What are these two methods? It's the net present value and the internal rate of return. So now we are going to take our first example. This first example will involve calculating the net present value method. To do so, we have a question here. Supposing a company intends to invest to $50,000 and the discount rate is 10%, and this amount is going to generate the following cash flows. Now notice these are cash flows. Please, NPV uses cash flows and not accounting profits. So over the 5 years, all the cash flows to be generated. So what is the NPV of this project? The NPV of this project, we can calculate. We've got year 0 there, 1, 2, 3, 4, 5, and also the cash flows. Year 0 is a cash outflow, 1 to 5 they are inflows. And using the approach we have discussed, we've got your discount factors here, 10%. Once you multiply, you get the present values, present. So all these now as at today. That is why we say present. So when you look at that outflow, compare this inflow, we've got now a net. And the net is the 10.06, which is a positive. So we have discounted our cash flows, we incorporated the time value of money, and we have an NPV of 38. What do you do with this NPV? The answer is the decision rule is to accept the project with a positive NPV. To accept the project with a positive NPV. So this project will take it because it's got a positive NPV. In the next part of our discussion, we're now going to look at the internal rate of return computation. So let's take a brief break and then we come to the internal rate of return computation.